So, hello everyone. My name is Dmitry Jemerov, and I've been working for JetBrains for most of my professional life, and I worked on a lot of things there, including I did lots of various work on Kotlin, and I wrote the co-wrote the Kotlin in Action book, and I was the lead of the Kotlin tools team for a while. Now I've moved on to IntelliJ-related projects, but I'm still involved in Kotlin, at least in the role that I'm giving talks at various events here. So I'm really happy to be here and to talk today about how you can develop multi-platform projects in Kotlin. So when we started working on Kotlin, our goal was to build a language that works, first of all, on the JVM, because that is what we needed, because we were building, like most of our products are built on the JVM, and we saw that there is an opportunity to build a language that better serves the needs of professional developers who work on the JVM. And well, looking at the conferences and looking at all the adoption of Kotlin in the industry, looks like we achieved this goal mostly. And once we reached that point, we set our eyes on other markets, like what can we do better to make even more people enjoy Kotlin. And every modern application is not just built on the JVM. It consists of many parts, many tiers running on the server, in the browser, and on the mobile devices. And of those, only the server and the Android run Java-based environments. So we decided to build support for Kotlin for the browser, for Kotlin Js, and for iOS. And we did not just want to support just writing and compiling Kotlin code to those targets. We also wanted to support the code reuse, so that you could use parts of your application written in Kotlin, just compile the same code to different platforms and run it in different parts of your application working together in concert. And what's important to mention is that our approach is not about making it possible to reuse all of the code of your application. So there are environments that allow you to do that, but we believe that if you want to build a great application, then it has to be tailored to the specifics of each platform that it's running on, to the specifics of the browser, to the specifics of the Android platform, and to the specifics of the iOS platform. And in order to make use of those specifics, you have to write platform-specific UI code for each of those platforms. So what we support sharing is just the common part that does not depend on the platform details, data model, validation rules, network LAN code, and so on. And for the platform-specific code, you have the choice. You can also write this in Kotlin. So Kotlin can be compiled to iOS or iOS native code or to JavaScript, or you can use the language that is native to each platform. So you can use something like TypeScript on the web, and you can use Swift on iOS. And it can fully interoperate with the shared part written in Kotlin. And of course, there's a bunch of, in order to build Kotlin, this common code, you have to rely on a bunch of libraries, and the Kotlin standard library is fully available on all the platforms. And there's a bunch of higher-level libraries that we have built and that we are still continuing to build that I'll talk about a bit later. So first of all, let's look at how a multi-platform project in Kotlin is structured. So in Kotlin, we have made the separation between common code and platform-specific code on the level of modules. So every module contains either common code that does not depend on any platform, or it contains platform-specific code. So in some cases, like the platform-specific code will be just mostly empty. So if you just have some data processing library that needs to be compiled to JavaScript and the JVM, then the platform modules will just describe how they are compiled and will not contain any code. In other cases, platform modules can contain a bunch of different code. And what's important is that common modules are not compiled by themselves independently. Because there is no cross-platform, there is no common format for executable code. So there is no target to which we could compile the common code so that it could be executed on any platform. So the compilation works on pairs of modules. So you take the common module, you combine it together with a platform-specific module for the platform that you are currently building for, and you compile the result using the toolchain for this specific platform. So for example, when you are compiling a Kotlin module to the JVM, you just take the Kotlin code from the common module, combine it with the Kotlin and Java code from the Kotlin JVM module, and compile it to class files, and then package the class files as the APK, whatever you need to package them. By the way, it's important to note that the common modules cannot contain any Java or JavaScript code. They can contain only pure Kotlin. Because our cross-platform toolchain works on Kotlin source code, it does not have any means to process bytecode or JavaScript code or anything else. Just in the same way, when you are compiling a Kotlin Js module, you take the common module and the JS parts and combine them together and produce JS files that you can then process with Webpack or whatever you need. And on the native, just in the same way, you get a native binary as the output. So the important part is how are you actually calling the platform-specific code from common code. So, for example, if in your common code you need to handle some case, okay, there is an error, I need to show the error to the user, and the specific way to show the error depends on the UI conventions of each specific platform. So you need to invoke a platform-specific function from common code. How do you do that? So in many cases, like in many other systems, the way you do that is basically by having an interface defined in a common code that is then implemented in the platform-specific code. This is not the approach that we'll use in Kotlin, and I'll explain why. But first of all, let's explain the approach that we do use. So in Kotlin, a common module can declare expected APIs. So it can say that it expects the platform-specific module to provide an API. In this case, it's a class that defines a method. And the platform-specific module has to have an actual implementation of this class. So there is an actual class date that matches the expected class date, and it has the getFullYear method that matches the expected getFullYear method. And because it's JVM code, it has full access to the JVM APIs. So here I'm using the java.util.calendar class to implement my date processing. It's not the most modern and not the best designed API, but this is what we use in the example. So yeah, so I'm implementing the getFullYear method just by delegating to calendar.get method. And on the JS, I also have an actual class, but in the case of JS, it's an external class. What this means is that I'm not writing out any implementations here. I'm just saying that this class is external, meaning that it's provided by the browser platform. So it's defined by the JavaScript framework, and it's just available to me. And because Kotlin to JavaScript compilation is basically a source-to-source translation, so the Kotlin compiler, just every time it encounters the usage of the class date, it will just output the date identifier in the code. And every time it sees this getFullYear method, because it's an external one, it will just output getFullYear to the generated JS. And then it's the responsibility of the developer to declare these external APIs correctly. And if they do that, then it will just run on the browser by virtue of having these APIs provided by the platform. And the way those things are matched together is by means of the package names. So an actual class has not only has to have the same package name as the expect class. So essentially, the common module says that it expects a declaration with the fully qualified name of Kotlin.date to be provided by the platform module. And in the common module, of course, you can also write code that calls those platform-specific modules. So, for example, this is same day function that is implemented in the common module, and it calls the platform-specific getFullYear function. So when this function gets compiled to the JVM bytecode, it will generate calls to this Kotlin.date class, which in turn will delegate to the calendar class. And when it's compiled to JavaScript, because the date class is external in the case of JavaScript, it will just be literally compiled to this from getFullYear equals to getFullYear methods. So why did we not use interfaces? So first of all, like the usage of interfaces, it's fairly involved. So there's a little bit of extra machinery that you need to provide, that you need to have in order to pass the implementation into the implementation of the interfaces to the common code. You would need some kind of factories to produce these instances. You would need some kind of dependency injection so that the common code can access the factory. And this is like a little bit involved, but that is not the main reason why we came up with the expect actual theme. So the main reason is that we do not want to restrict you with what you can declare as interface members. So for example, we can say that the expected class is expected to have a constructor, and interfaces cannot define constructors. So here we are saying that the expected class, that the date class is expected to have a constructor that takes a value, takes a number as an argument, so like the number of milliseconds since the epoch. We can also declare expected top-level functions and extension functions. So we can say that the platform code is expected to have a top-level parse-date function. And you cannot express this as an interface member. And for example, the Coroutines library relies very heavily on top-level functions, so we did not want to restrict ourselves to having interface members because this would just really hurt the readability and usability of the Coroutines library. And one other thing that this mechanism enables is that it provides us with an easy way to reuse existing implementations as actual implementations. So for example, the Kotlin.test library has an annotation that is used to mark the test classes. And we have made this an expect annotation. And on the JVM, we say that actually this annotation is just the ordered.junit.test annotation. So we say literally that like the Kotlin.test is actually a type alias to the existing ordered.junit.test class. And what this means is that when we compile our tests to the JVM, then the users of Kotlin of our annotation that we came up with ourselves are simply directly replaced with the users of the ordered.junit.test annotation. And this means that all the machinery that exists for running running JUnit tests, like all the IDE support and the continuous integration servers and everything possible, it starts immediately working for Kotlin tests of the common modules with very little effort on our part. And this is also something that would be really hard or impossible to accomplish if we just used interfaces. Now just a couple of explanatory slides showing how these modules are compiled. So this time the only build system that we support for multi-platform projects is Gradle. So for other types of Kotlin projects, we support everything for building them. You can build them with Ant, Maven, Bazel, basically whatever you want. For multi-platform projects, you currently have to use Gradle because we only provide the tooling as Gradle plugins. It's possible that in the future we will extend that, but for now, Gradle seems to work fine. And so we have the specific plugins for the compiling a common module and for compiling platform-specific modules. So a common module can have dependencies only on common libraries. So in this case, I'm declaring that my common module depends on the kotlin.sh-delib-common, which is the common version of the Kotlin standard library. And this is how I compile a platform module. So I'm using a different plugin in this case. I'm using the Kotlin Platform JVM plugin, and there are similar plugins for JS, native, and Android. And I'm adding one. Now I can depend on regular JVM libraries. So in this case, I'm depending on the Java version of the Kotlin standard library. And one other important thing that appears here is this expected by dependency. And this is how you link the two modules together, how you specify that this module is actually a platform part of this common module that is called conf-common in this example. So now let's talk a little bit about libraries. So I've already mentioned that there is no common executable format for common code. But still, you have to have, I already showed that we have this common libraries. How is that possible then? What do we compile to? The answer to that is that for a common library, you don't actually need to have any executable code for the library, because every time the library is used, it will be used for a specific platform, and it will be compiled together with the platform-specific version of that library. So the common library just needs to have the declarations so that we can verify that the APIs accessed by common modules using that library actually exist in the library. So what we do is we take the Kotlin code from the common library and compile it to something called Kotlin metadata. And this Kotlin metadata is basically what Eugenio's talk was about. So it's just basically serialized declarations of everything that is in the library. And so when you link to a common library, you just get those declarations. You can verify that you are using these correctly, but in order to compile your module, you need to have a platform module in addition to that. And this platform module will pull down the executable code for this library. Because when you compile the library for a specific platform, you now get like regular code that you get compiled to a jar in the case of Java, that you compile to JavaScript source code in the case of Kotlin Js. And in the case of Kotlin Native, we have something called a klib. And what klib is essentially a container, basically a zip file, that contains also those serialized declarations, also the metadata, and in addition to that, it contains the LLVM bit code. So Kotlin Native is built on top of the LLVM toolchain, and LLVM already has a platform-independent representation of like native code, which is the bit code, which can then be translated to platform-specific code every time you compile this to a native binary on a specific platform. So basically, we just compile this to bit code and ship the bit code as part of the klib. So now would be a good time to ask me some questions about all this multi-platform machinery before I move on to other things. OK, so if there are no questions, then let's move on. So now we want to talk a little bit about the specific libraries that we have built for the multi-platform environment. So this reflects like just the current state of our work. There is a lot of work going on, and there are actually maybe some things may have appeared that I'm not describing here, but this is very much in motion right now. So first of all is ConstantTest. So of course, when you're writing code, you want to cover it by tests, and of course, we provide a testing library for multi-platform code. There's absolutely nothing special here. We have annotations to mark tests. We have before and after annotations. And we have a bunch of assertion methods. There is nothing really fancy going on here. And when this gets compiled to JVM, those tests become regular JUnit tests, as I already told you about. And when you compile to JS, those tests can be run using Mocha under Node.js. So the next thing is actually much more interesting. It's called the CottonXHTML library. And what this library is, basically it provides a DSL for generating HTML code from Kotlin source code. And there are a few reasons why this is interesting. So yeah, first of all, this is statically typed, so like the compiler verifies that your code is actually valid, but that's not the interesting part. And also you get completion for attributes and tag names and stuff like that, but it's not very interesting either because you get this in any modern editor. The interesting part is that with Kotlin HTML, you have the full set of abstractions built right into this DSL. Because this is a DSL built on top of Kotlin, so it can make use of all the features of Kotlin to create abstractions. Because as soon as you start writing, because in any real project, you don't just have static HTML pages. So maybe you have a couple of them, but most of the code is not static HTML pages. They are templates that combine static code with user content and with stuff like loops and conditions and includes and some kind of blocks that nest with each other, and maybe you have some kind of framework that lets you build components. And none of this is provided as part of HTML. So you have to come up with an external tool, something like Velocity or FreeMarket or GSP or anything else. There are a huge variety of those tools that let you express that. And those tools usually they have restrictions. They are usually not as flexible as what a full-fledged language can do. And most of them don't allow you to do that. So if I just switch very quickly to the IDE, this is shared, source main render. So this is just some fragment of CotlinXHTML that renders the message. And I'm just going to do this. And basically just do a regular extract method refactoring. And this is like a completely trivial thing here, but this is not what you can do with normal template language. You can, like even with the support of IntelliJ, you usually cannot just take a block and extract it to some method and then to wrap this method into a class and have multiple implementation of this class for different contexts. So this is not as easy to refactor. And with CotlinXHTML, it's just trivial. Of course, this approach has downsides as well. So if you're using CotlinXHTML, you have to live with a bit longer feedback loop, because if you change a template, usually it can be rendered in just basically instantly. And with CotlinXHTML, you have to recompile and hot swap, and this takes a few seconds, even with Kotlin's incremental compilation support. And also, this is a little bit of extra learning curve for people who have learned HTML but didn't learn anything else yet. But still, we find this approach very, very useful in our projects. And one other huge advantage is what I'm going to show in my demo a bit later, is that this is a multi-platform library. So I'm talking about, so this presentation is about multi-platform projects, and CotlinX.html is a multi-platform library. So what it allows you to do is it allows you to use the same code for rendering parts of your application UI on the client and on the server, the so-called isomorphic rendering. So right now, basically usually people who talk about isomorphic rendering are JavaScript developers, and they are trying to find ways to run their fancy JavaScript single-page application library on the server so that they could provide a static version of their application for faster initial page displays or for search engine indexing or for other cases like that. Here, basically, this is part of the package that you get. So you can use the same code on the server to render the initial UI of the application, and then if you have updates or like changes made by the user, you can re-render parts of your application using the same code running in the browser. The next thing that I want to mention is the CotlinX.serialization library. So once you have these, like this data model of your application that's split between different tiers, you immediately come up with the need, you immediately realize that you have the need to ship the instances of those models back and forth between the different tiers. And CotlinX.serialization is the tool that allows you exactly that. So it's a compiler plugin. It does not depend on the reflection library. And it basically generates serialization code for your serialization, deserialization code for your classes. It's pluggable in terms of data formats it supports. So out of the box, we support JSON and protobuf, and I believe something else called CBOR, and I think there was a couple of other things maybe. But it doesn't matter. So if you are using something else which is not supported out of the box, it's very easy to write a plugin, and it's also very easy to extend serialization to custom data types such as dates and stuff like that. And finally, just a brief mention of CotlinX.Coroutines. So coroutines is how we do asynchronicity. There is enough material about coroutines to do one or at least 2 or 3 full-size talks, so I will just mention it very briefly. So coroutines are now supported on all the platforms, and basically what the compiler support for coroutines allows you to do is basically it turns a function into something that can be suspended and resumed. So this lambda, for example, can be suspended at the place where like when one asynchronous function is called and the place where the other asynchronous function is called. It then can be resumed. And then on top of that, you can build all sorts of primitives like for async await styles usage that exists also in C# and JavaScript. Or you can build something like Python's yield and generators, and there's a bunch of other things that you can do. And the key thing is that all of those specific primitives are part of the library. So they are not hard-coded in the compiler. If someone comes up with different concurrency primitives, they can implement that on top of the existing compiler machinery without touching the compiler itself, and this is super powerful. There's a bunch of other stuff that we are working on. So I/O is a big thing, so like buffers and sending buffers over sockets, writing buffers into files, and so on. HTTP, we are working on a cross-platform HTTP client. TCP as well, of course. WebSockets probably going to be covered, although I'm not aware. I don't know if there is any specific action on WebSockets going on already. Of course, we want to have a cross-platform representation of dates. So in my demo, I have something like I rolled together myself, but it's not very robust. And of course, we want to have some like officially supported solution for working with dates. And there's much more in the plans. And we have a bunch of sample projects that are built of multi-platform applications. So the first one is the application for the Kotlin Conf app. By the way, the slides are published, so you don't need to take pictures. I will tweet the link to the slides later. And the second one is actually what I wanted to show now, the KXHTML isomorphic. So this is actually, the application itself is very simple. So now, first of all, let me run this. So it's an application, like while it's starting, I can just show you a little bit. So it's an application built fully with Kotlin. It has a backend, a frontend, and some shared code. So now it's running, and I can open the page in the browser. And basically what it does, it shows the latest commits from the Kotlin project on GitHub. And the interesting part about this is that if you press view source, you see like the first, there are like, the first 5 commits are there. And everything else is rendered by, is rendered subsequently. So there's a bunch of JSON messages received by the application. I hope you can see this. And it renders them on the client to the same, exactly the same blocks as here. So how did we do that? So let's go back and look at the code. So first of all, let's look at the shared code that we have here. So the first thing that the first thing here is like the message. This is like the data model of our application. In this case, it's very simple, it's trivial, but in a real application, it would be much more. It could be much more complex, and you can have a very complex data model, basically. And so you have the normal strings here, and you also have the date class. And the date class is exactly this type of multi-platform class. So it's an expect class, for which the IDE shows us that there is a bunch of actual declarations. And if you click here, we can navigate to the JVM actual implementation and also to the JS actual implementation. The JVM actual implementation uses a bunch of Java standard library functions like the calendar and the simple date format. And basically, it's a fairly straightforward thing, so nothing very special here. Just a bunch of actual fun. Yeah, we like talking about actual fun. And the JS, as I already mentioned, the JS is an external class. So basically, this is provided by the browser environment for us. And for the paths that are not provided by the browser, we just wrote a couple of very simple implementations, like for formatting dates and stuff like that. So if we go back to the message class, the next thing we see is the serializable annotation. And this is what links in the CottonXHTML library. And this basically basically allows us to serialize message instances to JSON. And the way we access that is that we are, like, here's how we use the Kotlin serialization library. It's very easy, so I'm just using json.stringify and json.parse. And all these serial context thing exists so that I can plug in my custom serializer for the date class, which I made myself, so I need to provide my own code for serializing instance of this class. And finally, the key thing of this demo is this random message function. And this is once again, this is part of the common code. This uses the CottonXHTML library, and this renders my message to a bunch of an HTML div. So this function is used both on the server and on the client, exactly the same code, completely testable as cross-platform code, and it just basically lets me reuse my web UI between the server and the client. And the next thing we have in our common code is tests. So here I have a very simple test for my date class, and the interesting thing here is that I can run this test both as a JVM and as the JUnit and the Mocha. So when I select this run option, I get two entries here. So for JUnit and for Mocha. And let's try running them both. So you see that now this is like Java virtual machines, something. There's a JUnit somewhere here, and basically our test has passed. And now I'm going to delete this one configuration, create a new one. So once again, I'm right-clicking my date test class, selecting run, and selecting date test for Mocha. Now the same code gets compiled to the JS. Actually, it was compiled already, just scans that everything is correct, everything is up to date. And you see that now I'm running Node and Mocha and the same code, the same test. KXHTML is isomorphic JS test. So you see very, very easy way to test that your cross-platform code actually works in exactly the same way on both platforms. Now a few other things that I wanted to highlight here. So first of all, let's take a brief look at the backend. So the way I build the backend is I use the Cater library. And the Cater library is something that we have been working on at JetBrains for quite some time now. And basically, this is our attempt to build a completely Kotlin native Java server library. So of course, you can use something like Spring Boot with Kotlin. And if you look at the talks that Spring Boot guys do now, like the Spring guys do now, basically 2/3 of their conference talks are about Kotlin, so you can say that they are happy to use it. But we still try to see how a web framework would look like if it was built up from the ground up with all the features that Kotlin provides, like DSLs and coroutines and stuff like that. And it turns out that it's really nice. So the performance is really good. So I don't have any numbers right now, but we are using like this tech something benchmarks and Tech Empower, I think that they are called, is like the suite of benchmarks comparing various various web development frameworks, and our results are very good on those benchmarks. And the library is really easy to use and really composable. So basically, instead of just getting a huge set of features out of the box, you can basically pick and choose what you need. So in this case, I'm installing a number of plugins that basically give me like status pages and headers and stuff like that. And this is the routing part. So here I say how I respond to calls to various endpoints. So like this is how I render the index page. And this is how I send the JSON for the new messages. And very straightforward code, very easy to understand. And the index page is also rendered using CottonXHTML. So just nothing very fancy here, just a body and a div and some script and style tags. Quick look at the JS. There is nothing too fancy there either. So some usage of coroutines. So I'm using async here to fetch the new messages. And I'm deserializing them, and I'm rendering this using my command code to a div. So basically, that's all the interesting stuff that I have in my demo. So with like rather little code, I have implemented this isomorphic rendering concept, and it's actually a very great way to build web applications. All the web stuff that we're building at JetBrains right now, we're using Kotlin. All of it uses CottonXHTML. So now let's move on. This is not everything that I have. I wanted to show a little bit more about Kotlin native and about code to use for mobile applications, which is like a bit, I guess, also quite a hot topic. So as I already mentioned, Kotlin native uses an LLVM-based toolchain, and because the iOS tooling also uses LLVM, that means that we cannot worry that Apple is going to change something completely and Kotlin native will stop working, because we are using the same toolchain as they do. So if they change the hardware platform for iOS or macOS, or if they change how the apps need to be uploaded to the App Store, we can deal with that. Just like with all other flavors of Kotlin, interoperability has been a strong point for a huge area of effort for us. So we want to be able to seamlessly interoperate with native code. And the way we do that, we have built a tool that basically sucks in a bunch of header files and spits out a klib file that allows you to access this native library from Kotlin code. And it's built on top of CLang, on top of the standard C compiler, so it's not just a bunch of regexes stitched together. It has an actual proper parser, and it supports all the C types and also Objective-C types, because we also provide interoperability with Objective-C APIs, which is essential on macOS and iOS. So just a quick screenshot to show that you actually do have full access to all the iOS libraries on when using Kotlin native, and a piece of code that uses some of those libraries. So I'm personally not an iOS developer, but I can immediately say that if the identifiers are that long, this must be iOS. So yes, this is some code that uses the integrates with the Game Center, which is a completely native API on iOS. So like this has to be platform-specific code. And the interop also works in the other direction. So if you want to write your iOS application in Swift rather than in Kotlin and just reuse the common parts, this is what allows you to do that. So basically, you can take the shared part of your application and compile it to an iOS framework. And we automatically generate the header files for that. And so you basically just need to link in this framework into your iOS application and just run with it. And we also support conversions between the Objective-C native types and Kotlin native types. So it's on the JVM, these conversions do not exist because we just use the native types as they are. On Kotlin native, this is not possible, so we have this extra level of conversion and wrapping, but it's supported and it's easy to use. For memory management, what we have right now is a somewhat, I will not say peculiar, but so the architecture that we have now is that we do not have a full-featured garbage collector as on the JVM. What we have instead, we have heaps which are specific to each thread. So we don't have any mutable state between threads. So every memory allocation happens in the context of one thread. And for this memory allocation, we have a reference counting and a simple cycle collector. So that if you have two objects that reference each other and each of them holds a reference to the other one, so the reference counters never actually go to 0, but we still can detect that those objects are not referenced by anything else and collect them and free the memory. And if you want to pass things between threads, you have this feature called frozen object. So basically, you can create some object and this basically frees it and says that, okay, so this chunk of memory is no longer mutable. I'm done setting this up. And then once you freeze it, you can ship it over to a different thread, to a worker, or back from the worker to the UI thread. And in the UI thread, in the other thread, you can just take this object apart and do actions based on the data that you received. So this freeze stuff is, by the way, specific to Kotlin native. So there is no sane way to implement this either on the JVM or in the browser. But in Kotlin native, we have much more control over the runtime environment, so we can do things like that. And this is still under design, so we are reviewing this based on the feedback that we receive and the use cases that we discover. So it is possible that the final version may be somewhat different. But like this is what we have right now. So Kotlin native is not yet released. It's in version 0.6 or something like that now. So this is still under heavy development. As for the target platforms, since we use LLVM, we basically support everything. So all the desktop platforms, all the mobile platforms, we support WebAssembly, which some people find really cool, but I personally think it's not as useful as many people think. But we'll get there. And we also support embedded, so we actually want to relieve the embedded developers from the pains of using just plain C and give them finally a modern tooling that can still work in their environment. So unless you have like a really, really small device, you can use Kotlin native to build your embedded software. So the smallest binary that Kotlin native produces is something like with the current version is something on the order of 150K, so you don't have to have a lot of memory to use it. With 4K, you need something like native, but for like if you have a bit more memory, then you can use Kotlin native. For the tooling situation is right now a little bit of also in flux. So right now what we have are plugins for C-line and app code. The plugins are basically a full feature, so it's just a repackaged version of the Kotlin plugin that integrates with the native debugger and has its own test runner. We plan to provide a single ID which you will be able to use to develop all parts of your multi-platform Kotlin projects. So right now you have to use a separate ID for the native part and a separate ID for Java and JS, because C-line does not include any support for Java and JS, and IntelliJ does not have any support for native debugging, essentially. So we are thinking how we can provide a unified solution, but right now there are two separate tools that you have to use. Just a couple of screenshots to show that the tooling works. So the debugger works, call stack, watches, breakpoints, all the usual stuff that the debugger does, it's supported. And the test runner works as well. And in the Kotlin native project, there is a whole bunch of samples that demonstrate interoperability with different libraries and like various apps that we built with Kotlin native and so on. So now let me show you another demo. This demo will actually do this. Where's my Android Studio? Why is it so small? So basically what I did here, or not I, what my colleagues did here, is they built a calculator that is basically built a multi-platform calculator. So they have a bunch of logic to evaluate mathematical expressions. Like this is like arithmetic parser. It's probably one of the most sophisticated calculator implementations that I have ever seen in my life. I have no idea why it's so complicated. I should probably ask them, but anyways, it parses and evaluates mathematical expressions using fancy Kotlin code. And what we also have here is we have an Android application that basically uses this parser, this parse and compute method. It actually comes from this arithmetic parser module, and it's an Android application. And we also have an iOS application using the same code. So I have the Android app running in the emulator here, so you can see that it actually works. You see that it's very precise, so for 2 + 6 it enters 8.0, not just 8, because you have to be precise when calculating mathematical expressions. And by the way, there was a typo here that I didn't notice before. Okay. And I have the same app running as in the iOS, like very similar, and now I have an iOS application running the same underlying logic. So 2 + 5 = 7. For some reason, it does not enter show the 0.0, because I guess there is a bunch more logic implemented here. And here I'm going to switch to Xcode. And you see that I'm having now this Swift code. So it's called parser, parse with partial. This parser is exactly this Kotlin arithmetic parser. So it calls like parse with partial, then expression, and basically this is all calls of my Kotlin framework from my Swift code. So basically, once again, I'm reusing the business logic of my application between Android and iOS very easily. So that was my second demo. And second, the last demo. And before I proceed to Q&A, I'll just mention a few things about Kotlin Js. So first of all, one of the things I wanted to mention is that when you write Kotlin Js, you have the possibility to access JavaScript libraries in a statically typed way. So even though JavaScript itself is not statically typed, there is this wonderful project called TypeScript, and they built something called definitely typed, which is a set of static type definitions for all possible JavaScript libraries, which are community maintained and kept up to date and really exhaustive. So what we have a tool called TS2KT that takes those wonderful type declarations from TypeScript and converts them to Kotlin. And of course, the type systems of TypeScript and Kotlin are not exactly the same, so the results of these sometimes require hand tuning. So now we have a project where we publish basically our own versions of converted declarations, which are already hand tuned so that they work fully with Kotlin. And basically, yeah, so what those definitions allow you to do is access the code in a fully JavaScript code in a fully type-safe way. So once you take those declarations and produce JS code, then you use regular tools like Webpack or basically whatever you use for front-end development to package this to a bundle and run, or basically to embed this code into your JavaScript app. And this is basically the type of stuff that TS2KT produces. So this is just these are the same external declarations that we have already seen in the date example. So it basically says that, OK, there is a window class that's provided by the environment, and it has a location and alert, and there is a top-level window variable. So for the standard JavaScript library, we ship those declarations as part of the Kotlin standard library. For community-developed libraries, you would use TS2KT to get those declarations for you. And the second possibility that you have for accessing JavaScript native stuff is to use a dynamic type. So this dynamic type is a feature which is specific to Kotlin Js. So this is another platform-specific language extension. And basically what this allows you to do is to say that, OK, this is something, this is an object, let me do whatever I want with it. So it's just a JavaScript object. So in this case, I'm just taking the result of calling some API that gives me back a JSON. And I do not want to describe the scheme of this JSON statically. I'm just too lazy for that or whatever, or it's too dynamic. And so I declare this as dynamic, and then I can just access .messages and .text. And I don't need to declare these .messages and .text anywhere. I'm just calling them. And once again, this is a source-to-source translation, so the generated JavaScript code will have exactly the same .messages and .text. And the result of this will also have type dynamic, of course. And if I want, I can cast it to a regular type, and if I'm wrong, then the cast will fail at runtime. We support bindings for React. So you can build React apps with Kotlin in a fairly nice environment. So there is an NPM tool that will generate a boilerplate of a React application for you. The application will use our officially supported bindings for React. So yeah, you have full access to this ecosystem. You can very easily use React components and everything like that. We do not support Angular at this time because, like for this, we would need a bunch of stuff that the JavaScript compiler does not yet support. So I have no information on whether it's a priority right now, but yeah. Now it's just React, basically. And we also have built a Gradle plugin that integrates with all of JS-specific tooling. Like it downloads dependencies from NPM, runs Webpack for you to create a bundle, runs Karma for you to run tests, supports hot reloading of changes. So basically, all the workflow that you need is supported by this Gradle plugin. So to summarize, write your platform-independent parts in Kotlin: business logic, data model, validation, network connectivity. For the platform-specific parts, you can use Kotlin with full access to the platform APIs, or you can use the platform-native languages like Swift or TypeScript and have full access to the Kotlin APIs and, of course, to the platform-native APIs as well. And on every platform, like interoperability in both directions is like major strength of Kotlin. And there is a stack of common libraries that we are building to support all the scenarios that you need in your common code. If you want to learn more, there was this Kotlin Lang website and the blog and the Slack, and I also wrote a book which has nothing about any of that because it predates the multi-platform work, but there's going to be a second edition eventually, which will hopefully cover that. And thank you, and we have plenty of time for questions. Thanks.
Hi. So, of course, the example with the common module, I'm here.
Yep.
The common module was quite simple.
Mm-hmm.
Could you tell us about a real-world example? How do you use this common interoperability at JetBrains?
So right now I build something called Circlet. If I have internet, I may be able to show it to you. So it doesn't have my login. So basically, this is basically an you can call it an internet portal or an information or application lifecycle management tool. So it's basically a tool that integrates designed to integrate all of the development process in the company. This one. And it's a multi-platform application. It's a multi-platform application that uses like Kotlin everywhere, and it uses this multi-platform stuff and CottonXHTML.
And so, what are the types of common stuff? Like only the HTML and data classes there? Or
I'm not too familiar with the code. Sorry.
Oh, okay.
I don't work on this project, I just know that it exists.
Okay, thank you.
Okay, so are there any other real-world usages of these multi-platform libraries or Kotlin.js or Kotlin HTML, DSL?
For Kotlin Js, there is several front-end development libraries. There's one older one, and there was a new one that appeared recently. I don't remember the names. But I'm not aware of that many users, and I'm not aware of... So I think I've heard mentions of people saying that they already use this multi-platform stuff in production, but I don't think there's any public. They didn't write publicly about this, so I'm not sure. Even if I remembered the names, I'm not sure I could talk about them. But there are people interested in that. Okay,
so it's production already. This but it's production already. This Kotlin JS and this multi-platform.
Kotlin JS is production ready. Multi-platform projects are currently experimental, so you can use them in production. They will not break, but the design is not finalized.
Hi. So this sounds like to be a pretty massive effort. This whole cross-platform initiative.
Yeah.
Can you speak a bit about the size of the development team that supports all these various threads?
So the full size of Kotlin development team is, you can actually see this right here. So you see that there is like all in, is there common numbers? 53, yeah. Like, so this is how many people we have working on Kotlin altogether. And basically, so there we have like 9 people working on the libraries, 8 people working on native, 4 people working on JS. So yeah, there's a fairly sizable team.
Thanks.
I saw that you are able to use Objective-C, C++ libraries from Kotlin code because you have a tool which generates the headers and stuff. Can you call third-party Swift libraries as well?
Not right now. So there is, at this time, there is no direct interop with Swift, so you have to use the Objective-C APIs. I think we plan to support Swift, but I have no idea how difficult it is and whether there are like any major obstacles right now. But right now, Swift support, direct interop with Swift is not available.
Okay, thank you.
Hi. You mentioned about the native backend, basically, that you have a single memory per thread,
Yep.
and then you can freeze objects and you can move them across threads. Can you go a little bit into the implementation details for that?
Sorry, I cannot. I'm not very familiar with the details of that.
It's okay, thank you.
So if I want to use Kotlin for cross-platform projects in my business logic, what kind of limitations are there for libraries? Can I use libraries at all? And if so, what are the limitations?
So basically, common code has to reference only common libraries. So this means that if there is an existing library that you want to use from your common code, you have to build a facade for it using this expect actual declaration, and you have to provide the implementations of the parts of this library that you use for the other platform that you are targeting. So like there's basically this is basically what you have to do. Or you can rewrite this library in Kotlin and then compile it as a common library for the two platforms that you support. And in some cases, this may not be too difficult, so you can just, for some libraries, I guess you can just run Java to Kotlin, J2K, the Java to Kotlin converter, and just get some code, get it to compile, and compile it to different platforms. For some libraries, this should be fairly easy to do. There's a question here, or the one there as well.
Hi, you said that you're planning to develop a tool that will unite basically all about developing multi-platform projects.
Yes.
Will it include Kotlin native? Since for now, I think we don't have a community version of CLine. Yeah.
This tool, yes. So we will plan to develop a tool which will include all platforms in a single tool, but it will not be free and open source. So there will be no. At this time, we do not plan to provide a free version of our tools that will support debugging of Kotlin native code.
Okay, thanks.
So you will be able to do some work with Kotlin native. So they will probably understand. You will be able to edit the code most likely, but not debug it or not integrate with all some native specific tools. Yeah, there.
Hey, I was just wondering, the roadmap for Kotlin Js, would you be able just to let us know what the plans are over the next year, or is that publicly available?
I'm not fully up to date on that, sorry. So,
is there anywhere we can check up, or where we can see updates of?
Sorry, I cannot hear you.
Is there anywhere online we can see updates of like what the next plans are for roadmaps?
We are not very good at publishing roadmaps, sorry. So there is a lot of stuff that we actually don't like to make commitments in terms of anything. So for the language evolution, we have this keep thing, which is basically a process where you can suggest implementations suggest enhancement to the language, and we write for the things that we want to enhance in the language. We also write those key proposals, and they are public, so you can see them. But JS is not really language enhancements, and basically, I don't think there's a good way to track that at this time. Sorry. There's a question there.
Hi, I kind of got curious about that Ktor IO thing, because I had previously used Spring and database connections were done with Hibernate and stuff, and I was wondering if there are some kind of ORM or something similar, or JDBC connection or something using Ktor to, how would you do database connections with Ktor? That's the question.
So Ktor itself does not care about this. So you can use whatever, you can use Hibernate or anything else you want. But we have this library called Exposed, which is then basically our own Kotlin native object relational mapper thingy, which uses the Kotlin DSL to define the data model, and it provides a fairly nice API to. So you can basically you don't need to write any SQL, or there is no HQL or something. You just write all your queries as Kotlin code. So this is kind of somewhat unofficial, but this is something that we are using internally. I think the Circlet project is using that, and a bunch of other stuff that we are doing also uses Exposed. I think Circlet uses Exposed. I think it does, but I'm not 100% sure. So yeah, this is what you can use.
Thank you.
Hello, and
Hey.
Does Ktor support reactive stack and also database with reactive?
With Ktor, basically does not care, so you can use reactive stuff with Ktor. I think there are some adapters, I'm not 100% sure. For the databases, I guess, yes. So Ktor is basically entirely based on coroutines, so if you have a coroutine that produces data, then it does not care like where it gets the data from. You can wrap an Rx stream into a coroutine or something like that. I hope that answers your question. There was a question here for a long time already.
I have two questions, if you don't mind. So the first one, I heard that Kotlin 1.3 will gain the support of contracts, method contracts. So will the Kotlin native gain contract support?
For contracts are right, so there is no plans to make contracts available as a feature for the user's library setting. So right now contracts is, so basically for those who are not familiar with that, let me try to show this. Yeah, sorry. So basically, contracts allow you to specify that, for example, if a function, sorry, but I'll still better to show it if I can. Run symbol, run symbol, searching Kotlin dot run. Why doesn't it see my standard library? Wonderful. No, that's not what I want to see. Okay, so sorry. Maybe I will have better luck here. I have all kinds of exciting stuff, but not what I need. Yay, yay. So basically, there's a DSL that allows you to specify additional information on what exactly a function does. So for example, this run function is guaranteed to run the Lambda pass to it exactly once. And so we can use this in code analysis so that if you initialize some variable inside of a run, that we do not report it that it's uninitialized, because we know that run always runs the Lambda and does it exactly once. This is like, as of Kotlin 1.2, this is not used for anything, so this is there as a prototype. In Kotlin 1.3, this will be available for the library functions, so the compiler will understand those declarations which are part of the standard library, but it will not allow you to use those declarations as part of your own code yet. As for whether Kotlin native will support that, yes, of course, so this is compiler frontend, it does not depend on the platform in any way.
And the second question, will Kotlin Multiplatform gain the support for Kotlin native as soon as it make its way to release?
Kotlin Multiplatform already supports Kotlin native.
Already, yeah?
Yeah, so if you look at this, this is a native part of a multi-platform project, so it uses this, like, basically, yeah, so this is a native project. It has an expected by dependence on a common project.
Okay, thanks.
Hi. On the date example, when the JS implementation, you assume that the framework implement the getYear function.
Yes.
What's happen if I assume that the Java JVM does the same? Will I get a runtime error or highlight it?
So the compiler validates that all expected declarations have their actual counterparts. So like with the code will not compile if you don't have exactly the same declarations of get full year on the JVM and on the JS. And if you just write your external declaration for JS incorrectly, then you will get a runtime error because there is no way to validate this statically. Basically, there is no way for us to introspect the browser platform and see what types it supports. So basically, with this external stuff, you have to get this right. Otherwise, you will get a runtime error.
Hello. Can you just explain on the high level that what do I have to do if I want an iOS and an Android application, fetching some data from the network with the current state of the multi-platform? Like, what parts can I use in the common, or should I use like Alamo Fire for iOS networking and retrofit for Android?
For networking, we are working on an HTTP client right now. There is a prototype available. There is a prototype available here. It's going this is just personal GitHub of one of the developer who is working on that. This is going to be officially released as part of an official Kotlin library. So you can use either that, or you can use the native networking that exists on. You can use Volley and whatever exists on iOS for networking. Then you can use the Kotlin serialization. Then you can use the Kotlin data model, and basically you can write your common logic in Kotlin code. And then you compile this to a framework that you then access from your iOS or iOS code.
Thank you.
So looks like this is it. I'll be around for the rest of the day. I'll be happy to talk about anything related to like Kotlin or JetBrains or IntelliJ or like basically anything that we do at JetBrains. And so please find me and ask me questions. I'll be happy to chat with you. And thanks again for all the interesting questions.